Hey there! So let's continue our discussion about the various ways we can use to connect to an Azure data lake. And last time we covered this role-based access control method, which is pretty nice. But the main drawback of this approach is the granularity. Mainly, we cannot be more granular than a container. So if you would like to grant someone permissions to a specific directory or a file, well, that's cannot be done using role-based access control. But fortunately, there is yet another way we could use, and this method is called access control lists, or ACLs. And that's the topic for today, so let's get started. Alright, so ACLs, that's the topic for today. But before we go into them, let me revisit the RBAC thing, because last time I forgot to tell you about one thing. So when we were creating Azure Key Vault, I used this access policies method to grant access, which is the older method. It works, but its main drawback is that, alright, we have split into secrets, keys, and certificates, and we can grant specific permissions, for example, for secrets, like get or list. But we cannot be more granular. We cannot specify to which secrets we want to grant permission. So if we grant someone a get and list permissions, it will apply to every secret stored in our key vault. And it might be too wide in some cases, especially if multiple projects use the same key vault. So how to do it in a better way? Well, we could use the recommended way of granting access to a key vault, this role-based access control. And in case of this method, we will be able to specify access to every secret independently using those predefined roles. So that's how it could be done in a different way. Alright, so that was about Key Vault. And let's go back to our data lake and various methods we could use to connect to it. So last time we covered this role-based access control, which is fine, but we could grant access to a specific container only. That's the most granular thing we could use. Obviously, we could use RBAC to grant access to the whole storage account. That's completely fine. Or if we wanted to be more granular, we could set it at the level of given container. That's also doable. But if you would like to grant someone access to a specific directory, like this sales one, well, that's not possible. The same if you wanted to grant someone access to a specific file. Again, that's not possible. You should remember that we were able to grant that such granular access in case of shared access signatures, these two, service ones and user delegated ones, because here we were able to specify it even at the file level, so the most granular way it exists. So a way to do something similar is to use these ACLs, or access control lists, ACLs. And please remember that opposed to SAS tokens, here when we use ACLs, we will know to whom we are granting access. So finally, we would know who is trying to connect to our data, which is a huge advantage from security point of view. So ACLs, or access control lists. So first of all, they allow us to set access at any level. Like we might set it at the container level, or at the given directory, subdirectory, or specific file, whatever we need. And if you think about it, you should remember that in case of blob storage, the one that is not converted into a data lake by using this enable hierarchical namespaces checkbox, in case of this vanilla blob storage, we don't have those directories. There are only virtual ones, they do not exist. Which again means that in the case of them, we cannot use ACLs because those objects do not exist. So that's the first thing to be aware of, that ACLs, they can be used only in case of data lake. So data lake only. But usually it's not a big issue because we want to use data lake because we know its advantages and the reasons why we want to use it. Alright, but actually what are those ACLs, those access control lists? So simply put, these are three types of permissions we can grant on any level of our data lake. And those types of permissions are as follows: read, write, or execute. RBAC, that's the abbreviation. And when we think about those three types of permissions, they have a little bit different meaning when we apply it to a file or to a directory. So file, in our case, are those two yellow ones, and files and containers are above. So how does it work? Well, the first permission, R, it stands for read. In case of files, it is pretty simple. If you want to grant someone a read access to some file, we have to grant him R ACLs, those read ACLs. And that's it. Very simple. The same if you would like to grant someone permissions to write to a file, to modify it. Again, what we would have to do would be to grant this person a write ACLs on this particular file. And you should remember that we can set those ACLs at any level, right? So in this case, we can set them for this particular file only. And it works just like this. If you want someone to be able to read a file, we grant him read ACLs. Write, we grant them write ACLs. Alright, so that's simple. So how about these execute permissions? What does it do? And well, in case of files, it doesn't do anything. It's not used basically. But it has a very important purpose when we jump into directories. And actually, this is very nicely described in this documentation. I will give you a link in the video description. So in the case of files, as I said, those read ACLs, they are used to grant a read access. Write, well, as you can guess, they are used to grant write or update permissions to a file. And for execute, they don't do anything. Alright, so how about directories? So what do they do? Well, in case of directories, their meaning is quite similar. So for example, if you would like to grant someone permissions to a list, a content of a given directory, let's say this sales directory, what we would have to do would be to grant this principal, obviously, a read ACL at the level of the directory, plus execute permissions. Just like documentation says, that in case of directories, if you want to read the data, you've got to grant those two, read and execute. Then, if you would like to grant someone permissions to write to a file, for example, to create a new file in a directory, again in this sales directory, what we would have to do would be to grant this person a write ACL on this directory plus execute once, these two, and it would work. Alright, so let's get back to those execute permissions. So what is the purpose of setting them? So let's revisit our scenario when we want to grant someone read permissions on our file, on this data CSV. So what we would have to do, would be obviously to grant this person a read ACL on this file, because that's the access that is required. But please note that this file, it is placed inside our data lake. It has some hierarchy. So we've got this row container, then a SAP directory, then a sales directory. And whenever this principal that was granted access would like to get access to the file, it would have to traverse the whole hierarchy of our data lake to get access to the file. And by default, it is not possible. So to allow someone to traverse the hierarchy of our data lake, that's when we would grant these execute permissions on the parent directories to the very top. So in our case, it would mean that you would have to grant someone those execute permissions on our sales directory, because that's the parent of our file, then to the parent of the parent, in our case it is a SAP folder, and then on the root container. So this way, someone will be able to traverse the hierarchy to the file and then finally read our file. And again, that's something that is well described in the documentation, that those execute permissions, they are required to traverse the child items of a directory. All right, so that's how it looks like. And let me write two more important things about this access method. So first of all, it can be set up to a specific file, so it gives us a very granular access up to file. And actually, let's jump into Azure portal and let's see where we can set them. All right, so I'm in Azure portal. I am looking at my storage account, which is converted into a data lake. You can see it here that indeed it is a data lake. And let's jump into containers. And here inside row container, we've got our directories that we used in previous episodes. And for example, let's jump into images. We've got those two images. And what we did previously to grant access to this particular file when using SAS tokens was to use this generate SAS option. Now we'll use this option called managed ACL because we want to use ACLs instead of SAS. And basically this option exists on every level inside our data lake. Right now I'm doing it for a file. So let's jump into this option. All right. So first of all, you can see here those three types of permissions: read, write, and executes in columns. Then in rows, you can see various principals to which those permissions are granted. And if I would like to grant permissions for someone, I would simply use this add principal button. Let me find our demo user. That's the one. And let's grant him, let's say, read and write permissions and save it. And that's it. Those two ACLs were just created. And that's how it works. At the file level, at least. Now, it looks a little bit different in case of directories. And let me show it to you. So, in case of directories, let's jump into SAP folder and let's manage ACL on this level. So here you can see that we've got two tabs. Previously, in case of files, we had only this access permissions tab. And these access permissions, it simply stores those ACLs, those permissions that were granted on a given scope, in this case, in a directory. And it works in the same way that we have those read, write, and execute permissions. Then in rows, we've got various principals. We can add a principal, standard stuff. But what is new are those default permissions. So what are they? What's the purpose? So let's jump back into our drawing and let's think about the structure of our data lake. So a very important thing about ACLs is that they are set independently on every object inside our data lake. Or in other words, every object has its own set of ACLs that are not inherited. It doesn't work like in a Windows. It's a little bit different. So in our case, it means that this file has its own set of ACLs that are completely different from ACLs set on the second file, which in turn are completely different than ACLs set on a directory, and on this directory, and on a container. Each of them is a separate set of ACLs. They are not inherited by default. So it makes management of ACLs a little bit difficult, especially if you've got multiple files or multiple children inside some directory, and you would like to make sure that every child of your parent will have the same set of ACLs as the parent. And because every object has its own independent set of ACLs, there has to be some way to set default ACLs. And that's exactly what this default permissions tab is used for. And please note that it is valid only for directories, because only directories can have children, files cannot. And first of all, we've got to configure those default permissions. And then it looks in the same way as in the case of regular access permissions. We've got those read, write, execute permissions and various principals. And how does it work? Well, simply here, using default permissions, we can define a set of ACLs that we want to be granted automatically for every new child of this object. So let's add new default ACL for demo user, and let's grant him read and write access as default permissions. In case of access permissions, he doesn't have any, right? But default permissions are the ones that will be automatically set whenever a new object is added to this directory. But again, it is very important to remember that it applies those default permissions only to new objects. And it is also mentioned here that it applies to new children of this directory. So we can verify this by going into this SAP directory and checking ACLs on the sales directory. Right now, this demo user doesn't have any ACLs. Why? Simply because this sales directory, it already existed at the time when we set those default ACLs on the parent. So that's why they weren't applied. So what would happen if we add a new directory, let's call it, I don't know, HR, under this SAP directory, and this time those ACLs for demo user, they are applied. Why? Because they were inherited from default permissions set at the parent. So that's how it works. And please note that they are also set as the default permissions of this HR directory. So every file or every directory created under HR directory will also inherit those new permissions. So that's how we can make the management of ACLs a little bit easier. But it also requires from us thinking upfront how we want to design our security model. Alright, but what if we already have some data lake with some structure with thousands of files, and we would like to set those ACLs on various levels? And you know that we cannot use those default ACLs because they apply only in case of new objects. Fortunately, there is a way to propagate existing ACLs to all its children. But to do it, I will jump into a different tool from Azure Portal, and this tool is called Microsoft Azure Storage Explorer. It's a free tool, you can download it from the internet, and actually it's very useful in a case when you have to work with data lakes or storage accounts in general. Azure Portal is fine, but in many cases this tool is just more convenient to use. You can get your work done faster using Storage Explorer. And right now I'm connected to my Azure subscription and I have my data lake opened here. We can see those public row and test containers. So let's go into a row container. And in a SAP directory, let's again verify what kind of ACLs were granted. And to do that, I will simply right-click on this directory and use Manage Access Control List option, like so. The UI is a little bit different compared to the one that we saw in Azure Portal, but the behavior is pretty much the same. What is nice about Storage Explorer is that we've got access and default ACLs stored in a single tab, so we don't have to switch between them to see those two types of ACLs. And we can see that demo user has those default read and write permissions set at SAP directory. All right, but we can see that inside this SAP we've got sales directory and some file. And if we check ACLs set on the file, there are actually no ACLs apart from the out-of-the-box ones. So let's say that you would like to set some ACLs on this SAP folder, maybe for the demo user. Let's grant him read and write access. And right now what I would like to do is to propagate those permissions set at the SAP folder to every children. Just do a cascade update. And to do this, I will again right-click on my SAP folder and use a different option called Propagate Access Control Lists. And now, this option might cause some issues if you are not paying attention. So I strongly advise to practice this stuff on some test storage account to see how it actually behaves, what ACLs are being propagated, how it overrides existing ones if there exist. So when you do it on your production data lake, you won't be surprised. And actually they even tell us that this process cannot easily be reversed, so think twice before you do this. But let's say that I'm aware what I'm doing. So yes, I will click that I understand this behavior, and let's propagate those permissions set on the SAP directory level. And you can see in the message that it propagated those ACLs. So if we go down up to the file, we should see here those permissions set for our demo user that were propagated from SAP directory. So that's how we can propagate those ACLs. But again, pay attention to this option and test it before you do this in production. All right, so ACLs, this is a really cool option because it gives us the best granularity out there. We can be very specific, and when using ACLs, you can design a very good security model. And actually, in some future video, maybe I will show you how to do it in a proper way. Now, one cool feature of ACLs is that they coexist with RBACs. So they coexist with RBAC. And what do I mean by this? Well, those two options, role-based access control and access control lists, they simply cooperate. And Azure determines which one of them should be used depending on some various conditions. For you, it means that you don't have to choose whether you want to use RBACs or ACLs. You can use both of them, depending on your case. And now let me tell you how Azure checks whether RBACs or ACLs should be used. So let me draw some diagram. So let's say this is our start point, in case of which Azure would like to determine if someone should get access to some file or a directory. So the first thing Azure checks are role-based access control. Is some role granted to the principal that would grant him or her the required access? If yes, then case closed, access is granted. That's fine. So ACLs are even not checked at this moment. So you might use those data plane roles from RBAC approach to grant access, like storage blob data contributor or storage blob data reader, if you would like to use roles. If roles are not granted, or if not sufficient roles are granted, then what Azure checks are ACLs. Are they granted? And do they grant sufficient permissions? If yes, then the access is granted. If no, well, sorry, you shall not pass. And that's how it works. And basically, the best approach that I personally like to use is a combination of these two, roles and ACLs, just to be able to grant as granular access as it is required. All right, and basically that was it. So we covered those various methods we could use to connect to a data lake. We've got those the ones that doesn't contain the identity, like anonymous access, access keys, and various types of SAS tokens. And we had those two that contain the identity, like RBAC and ACLs. So actually, let's think about two cases, two scenarios, in case of which let's think whether any of those approaches would work. So what I would like to do right now is to write those two cases. So let me prepare a simple table like this. So let's analyze two cases. The first one would be that we want to grant someone read or write access to a specific container. But only to a single container, not to every container out there. So that would be our first case, like so. And the second case would be very similar, but this time I would like to grant someone read or write access, but not to a container, but to a directory, to a specific directory. All right, and let's show on a data lake example what I mean by this. So the first case is that I want to grant a read and write access to a specific container, let's say to the whole raw container or to the whole standardized container. The second case is similar, but this time I want to grant access in a more granular way to a specific directory, like the sales directory. And actually, let's analyze all those methods that we discussed so far. So let me add all those methods. So what methods did we cover? Well, we have anonymous access. That was the first option. Then we've got access keys. The next option was account level SAS token. Then we've got service level SAS token. Then user delegated SAS token. And finally, we've got the remaining two, which were RBAC and ACL. So RBAC and ACL. All right, like this. So let's think whether those methods would work in our case. And now, at this moment, what I want to do is to simply answer a question: will given approach work in our case? I don't want to yet determine whether it makes sense to use a given method or is it the best method out there, but simply, will it work? And if yes, why? If not, why? Alright, so the first case, we want to grant read and write access to a specific container only. And anonymous access, in this case, well, you should remember, it's already written here above, that it grants read access only. So no, for sure, it won't work, the anonymous access, because it doesn't grant us write permissions. And let's analyze the first case right now. Access keys. So will they work? And if you don't remember what access key was, let's revisit Azure portal. And here in the storage account, we have this access keys option that give us full admin access to the whole storage account. And again, because it gives us access to the whole storage account, then again, it won't work because it's not granular enough. Then the next option was account SAS token. And those SAS tokens were available again at the storage account level. And here we've got many options we could use. But actually, will it work in our case? And the answer is no, it won't. Why? Because when using those account level SAS tokens, we are not able to indicate to which container we want to grant access. We can set that, we can define that we want to grant access at the container level, but not at which container. So no, it will not work. Then we've got those service level SAS tokens. And just to recap, they are set inside our objects, like here, generate SAS token, and here we can set what kind of permissions we want to set. And in this case, can we do this at the level of specific container? Yes, like right now I'm doing for this raw container. We can generate a SAS token that would grant read and write access only, nothing more. So yes, this option will finally work. So service level SAS tokens will solve the first case. How about user delegated SAS tokens? And in this case, you should remember that the difference is quite simple. Simply, we use a different method of signing our SAS token instead of the account key, we use user delegation key, or permissions of the user who is generating the token. And here again, we can set it at the container level, and we can set the permissions that we want to be granted. So yes, it will work just fine. All right, so how about the role-based access control? And role-based access control, yes, we have information that we can set it up to the container level, so it gives us the granularity that we need. And we have those various roles that will allow us to set the required access. So in our case, we should use this storage blob data contributor role set at the container level, and it should work. So in our case, we would simply go into the container, then to access control tab, and we would grant someone this storage blob data contributor role. Storage blob data contributor role, and so on. And following best practices, we should do it using MS-Entra groups, not directly to some user. But again, it will work just fine. So we can mark it using a green tick that this approach will solve our case. And how about ACLs? Well, they are super granular. You can use them for containers. So for sure, yes, they will work just fine. All right, so we've got 4 options that we could use in this case. So which one should we use and why? Or which one I prefer to use in such cases? Well, and for me, the winner is obvious. It is role-based access control. It's the simplest method, the cleanest, and the best, because I wouldn't use those service or user delegated SAS tokens because simply we have no identity here. And in many cases, we want to know who is getting access to our data. So it leaves us with RBAC and ACLs options only. And out of those two, RBAC is simply simpler. It's easier to manage, easier to learn. So let's not overcomplicate stuff and use the solution that works. And in this case, it is role-based access control. And in many cases, this RBAC stuff is enough. But if you want to grant more granular access, then you have to use a different approach. And that's the second case. So right now, let's solve the second case, in the case of which we want to grant read-write access, but to a specific directory, not to the whole container, but to a specific directory only. And again, let's analyze all of those approaches that we just discussed. So anonymous access, well, obviously it will still won't work because it gives us read access. And secondly, it can be set at the container level, so for sure not. The access keys, again, they will not work because they give us full access at the whole storage count level. Account SAS tokens, no, we cannot be that granular, so no, it won't work. Then service level SAS tokens. So let's again jump into our data lake. So this time let's go deeper into raw container, and we've got those different various directories. Let's say we would like to grant someone access on a SAP level. Can we do this? Yes, that's fine. That's totally fine to generate SAS tokens at the directory level, which means that service level SAS token will work. The same for user delegated SAS token. The difference in this case is minimal. But how about a role-based access control? Will it work? No, it won't. Because for role-based access control, we cannot be more granular than a container. And here we want to go into a specific directory, so it simply cannot be done. But how about ACLs? And ACLs will work, because in case of ACLs, we can set them at any level, like we have in our case here, even at the file level. So right now, this ACL option would work just fine, and it will give us the access that we actually need. So again, let's think about the best option out of those three that would work in case of the second case. And for me, the winner are ACLs. Why? Again, because we know who is getting access to our data. And I know that ACLs they might be a little bit confusing at the beginning, just to understand how they work and what they do. But once you get familiar with them, it should be quite simple. And actually, when I'm designing a security model for a data lake, I use a combination of roles and ACLs, because together they are quite flexible and they just work in a very good way. And basically that's it about granting access or getting access to our data lake. We've got those various methods that we've just discussed. And you might think that, all right, but why should I care about this stuff? I'm a data engineer, not a security guy. This is true, but please remember that data lake is the place that stores your data. And in the case of many services that you will use as a data engineer, you will need to get access to this data lake, either to ingest the data, to write, or to read, like Data Factory, Databricks, Synapse, Logic Apps, or whatever tool you will use. And depending on the tool, the number of methods that are available, it might vary. And you should be aware about pros and cons of every method, so you could make a choice in a proper way. And that's it. Thanks for watching, and see you next time. Take care.